When we make a measurement, we want to try to obtain the most accurate number for that measurement. That is, we want to get as close to the true value of the measurement as we can. We often can make an analogy with a bullseye. The center of the bullseye is the value, the true value that we are aiming for. However, every time we shoot the arrow, we get close to the center of the bullseye, but we aren't exactly on the center of the bullseye. So every measurement, every shot on the bullseye is slightly different than every other one. And so even though we have hit the bullseye, we aren't exactly in the same place every time. So there's some uncertainty in where that arrow is going to land. So this brings up two important concepts: accuracy and precision. Accuracy is that we get close to the correct or the true value that we are trying to measure. So accuracy tells us something about how close we are to the true value, whereas precision is about how often we hit the exact same number. So what is the repeatability of those measurements? How easily can I repeat the measurement and get exactly the same number? So again, the analogy is this bullseye, where the number I am shooting for is the middle of the bullseye. And every time I shoot for the middle of the bullseye, I get a slightly, not quite exactly in the middle, a slightly different value. As you can see, the arrows are hitting very close to each other. And so I'm repeatable, and so I am precise. In addition, they are hitting very close to the middle of the bullseye, and so I am also accurate. Thus, this measurement is both accurate and precise. However, it is not exactly the same every time, so there is some uncertainty in the measurement. When I'm looking at this other example, I can see that the arrow has missed the mark every single time. So I'm not very accurate. I'm not actually hitting the spot, the true value, which would be the middle of the bullseye. So I'm not very accurate, and I am not very precise, right? My arrow is going wild all over the place, and so this is neither accurate nor precise. Okay, so because we can never actually get exactly the same number every single time, there's always going to be this uncertainty in our measurement. We're going to want to try to minimize that uncertainty as much as possible. As an example of why we can't actually ever get the exact true value, and that we're always going to measure something close to the true value, but with some error in it, can be illustrated by looking at this part of a graduated cylinder with some water in it. So you'll see that the water filling up this graduated cylinder that has markings on it in terms of milliliters. So this mark here is 1 milliliter. This mark here is 2 milliliters. And this mark here is 3 milliliters. We can see that the liquid comes up to 2.6, but it's between 2.6 and 2.7. So it's not exactly 2.6, and it's not exactly 2.7. So it's somewhere in between there. So if I have 3 or 4 of you determine what where the bottom of this meniscus, this dip in the water, if we look at it right at the bottom here, if I had 3 or 4 of you give me the number that you think that represents where that water line is, you would all give me some number between 2.6 and 2.7, but it's not exactly 2.6 and it's not exactly 2.7, and so I have to estimate how far away from 2.6 it is and how close to 2.7 it is. So for instance, I might estimate that this is 2.66 milliliters, and someone else might estimate that it is 2.65 milliliters, but someone else might think it was 2.67 milliliters. And so every one of us is going to measure this at a slightly different value because we're estimating that final digit. So the way that we might be able to minimize the inaccuracy or the imprecision of that measurement is by measuring it 3 or 4 times and taking an average. The average is always better than any given measurement. So the average of this would be 2.66 milliliters, and that would be the value that I might report as the volume of water in this graduated cylinder. So what an average does is it takes random fluctuations in that measurement, so random imprecision in that measurement, and if those measurements are truly random, in other words, if they are scattered about the true value, so here's the true value, and my measurements are a little bit above and a little bit below the true value, always maybe something's really close to the true value, but they're just randomly scattered about that true value, then if I average all of those, I will end up very close to the true value. So averaging averages out the fluctuations, the random fluctuations due to just the fact that we are always going to have random fluctuations in any measurement. So we always want to do more than one measurement, and we want to average those measurements to get closer to the true value. I can represent how precise my measurement is, what the precision of this measurement is, by looking at the spread in my values. So how far is the furthest value away and to the negative side, and how far to the positive side are my values? How spread out are they? So this spread in the values tells me about the precision. So any measurement is going to have the value that I think is closest to the true value, so the average. So we're going to have the average value, and then we're going to have plus or minus the spread in that value. Typically, what I do to represent the spread is I calculate something called the standard deviation. And this standard deviation tells me about that spread. For our purposes, we're mostly just going to look at what's the lowest value below the average, what's the highest value above the average. Look at that distance and take half that distance. So half that distance is the minus, and the other half is the plus in our plus minus. So plus minus tells me that if I subtract the half of the spread, I will get the lowest value that I actually measured. And if I add half of the spread, I will get the highest value that I actually measured. So this plus minus part tells us about precision. This average of all the measurements tells me about accuracy. So if I actually know the true value, then I can see how close my average is to the true value. The closer it is to the true value, the more accurate my measurement is. And then the larger this spread, the larger this plus minus value, the less precise my measurement is. So the bigger the spread, the less precise I have been in measuring. The closer everything is to the average, the more precise. So smaller plus minus means more precise. Larger plus minus means less precise.